Hi, I'm Alix Paultre, Editor-in-Chief of Electronic Component News, and today I wanted to talk about the disruptive technology of solid-state lighting. I say disruptive because we are in the middle of a sea change, going from vacuum tube, the last of the vacuum tube technologies, the CRT and the light bulb, to the new technology of solid-state lighting. Actually, the technology for solid-state lighting has been in existence for some time, but is only now getting to the point where it can be properly commercialized. But for all intents and purposes, the light bulb might as well just be another vacuum tube on a curio shelf, because there may still be vacuum tubes in use in the household in the form of light bulbs, but in a few years, especially given the fact that many governments are now banning light bulbs, the incandescent light bulbs, the light bulb will soon become a quaint novelty or a hoarded commodity, depending upon how you look at it. The CFL is sadly, at best, a stopgap, and because of the complexity, the bulk, the fact that it contains mercury, and is basically a reverse engineering attempt to try to keep with the Edison screw base, which of course is based upon old candlestick hole sizes. The fact that this legacy technology is still exerting a grip on us, it's about time for solid-state lighting to step in. The most common solid-state lighting that we are familiar with is, of course, the LED. Modern LEDs are at a brightness level and of a white level intensity to replace incandescence and fluorescence, but the marketplace hasn't yet gotten there. The products that you see on your shelves today are actually based on LED technology that is a couple of generations old. The latest LEDs that have been released today are only just now getting into product. In fact, the biggest area of the most advanced LED adoption is actually in display technology. Standard LCD uses a serpentine fluorescent bulb to create the light which the LCD turns into an image. But because of the fact that an LCD is a light filter and fluorescent light does not produce 100% white light, the color from an LCD is lacking. However, if you use red, green, and blue LEDs, you generate better white light because your color reference points are farther out on the scale than the very poor light produced by a fluorescent light. But solid-state lighting is more than just novelties for television sets. Solid-state lighting is more than just LEDs. A lot of people think of solid-state lighting and they only think of LEDs. But in reality, the LED is only the tip of the iceberg. There's Electroluminescent Cloth. This is a sample of a Super Flex from Crosspoint. They've been working on using this material in tents and such for lighting applications. And then this, for example, is, they call it the flat light bulb from a company called Sea Light. And it's flexible, as you see, and it lights up. Now, there is an audible piezoelectric effect. This beeps, or I should say buzzes, similar to the way neon lights buzz, but it's more from the electronics in that case. In this case, it's actually piezoelectric between the capacitive layers of the display. I mean, not display, of the lamp. The big aspect of this is that it's flexible and flat. This technology was actually used by several department stores this last Christmas for to replace light boxes behind ad gels and other types of signage. So for a commercial kiosk and outdoor signage application, this is actually quite a satisfactory solution. But again, solid state lighting. The whole aspect of solid state lighting will dramatically change the way we deal with things for multiple reasons. Number one, there's no glass. Number two, the technology, if properly implemented, is very robust and will last quite a long time. This is just a demo of how the LEDs are used in these televisions because in the case of an LCD, there's a light guide behind it and the LEDs are strung along the edge in the case of this one. So if you see there's an LED under this light pipe, but the light is channeled out at the end. And so just picture the edge of the television set just covered, or I should say one continuous sheet of a material like this that routes the light into the device. So whether it's solid state, LEDs, electroluminescent cloth, electroluminescent sheets, organic light emitting diode technology that's now out in the Nexus 1 phone, solid state lighting has gotten to the point now where it is a viable challenger for incandescence, and you can even get white LEDs in various color temperatures, so you can actually modify the light required to suit the application at hand. So LEDs, electroluminescent materials, and other technologies of that nature that form solid state lighting will eventually displace and take over for the incandescent light. And a good thing to remember is solid state lighting is not just LEDs. Thanks.